Welcome, I'm here to talk about RISC V. RISC V is essentially a computer architecture which has some unique characteristics that make it very interesting for the industry, starting from the fact that it's actually an open standard, and we have several members of the RISC V International Foundation contributing to the development, so it means we have an input on what we want. Secondly, it's a modular architecture, so you can have processors implemented RISC V in different flavors, composed of a base set and extensions depending on the instruction sets you need and the particular needs and the availability and the space of silicon you have. In the nRF54L series, we have it in the form of a coprocessor. Why do we call it a coprocessor and not a processor? Well, the main difference is that at the heart, the nRF54L still has an ARM Cortex-M33, which is the one that starts when the device powers up. However, there is a second execution unit that can be turned on and off by the Cortex, which is RISC V. So that's why we say we have a RISC V coprocessor, because it's not starting from the scratch, it's just you have to manually start it. Then we have two main use cases where you can use it, and we see several customers having very success with it. The first one is to offload the CPU. So for example, if you have an application CPU, you're struggling with time and you need some extra processing power, you can offload some tasks to the application set, so the RISC V coprocessor, that will actually keep your application separate in different domains. And for example, if you have time constraints or interrupt sensitive tasks, you can isolate them in the RISC V coprocessor and ensure your product will meet your requirements. The second use case is for soft peripherals. Essentially, soft peripherals are a way to emulate hardware in the RISC V coprocessor. The architecture and implementation of the RISC V coprocessor in the nRF54L series is optimized for high-speed input-output. That means that we will give you a firmware that, for example, will emulate a QSPI port. And in your nRF54L15, which doesn't have initially, you could use it just like with the same NRFX layer of drivers, completely transparent to you. And we don't know if you're talking with real hardware or not. That will also be useful in just building for different targets. And for example, one has it and the other not. So if you want to know more about this, I definitely encourage you to go to DevZone and check your blog post about it. We also have an on-demand webinar where you can check. There's RISC V standards are open, so you can go to the website, RISC V International's website, and check them there and learn more about it. And obviously, the best way is just get your hand dirty, get an nRF54L15 DK and start playing with the samples we have in the SDK.